Hi, everyone. This is Miss Neville, and unfortunately, I'm joining you virtually for our first science class. This is going to be a long video, but the good news is we'll get these videos every day from me. I'll upload them promptly at 8 o'clock in the morning each day. And I'm going to tell you the different places they can be uploaded through my YouTube channel and through Remind. And I'll always be available with you outside of these recordings through freeconferencecall.com, and I'll give you that link at the end of the lesson. So each of these videos daily will discuss one of the days in your packet. If you've not already noticed, this packet is completely review of energy. And today we're going to cover the first 3 days that you should have completed in your packet. I'm going to be helping you or bringing some things back to mind, but also be able to be there to tutor you during this video because it's a recording and after this video through freeconferencecall.com, where you and I'll be able to video conference with you using your notes and looking at your packet. Wednesday, we'll cover day 4, Thursday, day 5 of your packet, and Friday, day 6. If you'll take some time, pause the video if you need to, because I don't believe in reading PowerPoints to people. Take some time, read what you can expect from Miss Neville. When will I be available every day? How will I be available every day? And when can you expect these new lessons? So the expectations of you are to check in with me every day. You can do that through your email. If you want to send me an email saying, Miss Neville, I'm here today working on my packet, that's great. You'll always get a response back from me saying, okay, how can I help today? Or how were you successful in your packet work today? How were you unsuccessful? Where can I help out? You also want to make sure you're working on that science packet every day, okay? So let's get into the nitty gritty. Day 1. When we're looking at energy forms and forms of energy, we come back to mind those 5 types of energy we've discussed. Amen. You'll find too, y'all, it's really tough for me not to comment and talk to you guys. I have to remind my crazy self that this is a recording and nobody's looking at me right now and talking back to me. But you'll see. And maybe sometimes you can yell back at it. Ain't no shame. Yell back at me. That's okay. I love how in this packet there's some days for you to journal where you're actually writing down in sentences, drawing pictures, explaining your learning. That's a better way of learning than any multiple choice test. We want to look here first, and we see here that we see the different types of energy. When you look at gas and food, do you not see that that is what type of energy? CH. Chemical energy. When I look at the sun, did you think of solar energy? You would be right. But also I want you to think of an R energy, radiant energy. And when we think of radiant energy, remember it's not just sunlight, it's any light. So a lamp that's illuminating light is a source of radiant energy. We see that little guy there being electrocuted. What that is an example of, I gave it away, electrical energy. Energy that flows through an electrical circuit. We see those at the bottom left. We see those different types of heat energy. And if you remember there from what we learned in school when we were together, I don't call that heat energy. I call it thermal energy. Very good. And then we see that roller coaster picture. God knows we've looked at a lot of those different pictures of roller coasters. And we see there at the top of that hill, that's potential energy. That coaster box has the potential to move. And once it starts to move, what's our energy of motion? You guessed it correctly, kinetic energy, okay? So we want to think about our section quiz that you're now taking or should be working through. One of those questions talks about what heat causes atoms to do. And we use the word atoms in class, but we also use the word particles. And remember, with our fist, heat causes particles to do what? Look at the PowerPoint. Spread apart and move faster. So when we're thinking about heat, that's what it causes particles to do. And that gives us right into our conversation about fluids. There are two types of fluids that we learned about as sixth grade scientists, gases and liquids. They're both considered fluids because they both behave very similarly. They share some key characteristics. Fluids are spread apart, their particles are moving faster. And so that's what we know there about fluids. And isn't that true of gases and liquids? Absolutely. We're going into day 2. And if I'm going too fast at any time, this is a recording. Feel free to rewind it, pause it, so that you can read some of the information I have on the PowerPoint. Or if you need to hear me say something again, let me know. Or I'm available right now through video conferencing. You can contact me that way too. So the law of conservation of energy states, remember, energy cannot be created or destroyed, but only transformed. So when we're working through the law of conservation of energy and we know everything about these forms of energy, isn't it important that we understand that stretched rubber band, that's the lab we did at the very beginning of the year. If I stretch my rubber band a lot, my rubber band will possibly move really far, travel very far. But if I only pull it a little bit, it won't go very far. That's because of the law of conservation of energy. In other words, I cannot get what I have not given. I cannot eat only an apple and expect to run a 6-mile marathon. It won't happen. I've not given my body the chemical energy it needs to produce kinetic energy or energy of motion. Day 3, we're looking at the electrical circuit, and it's fine for us to answer questions about series and parallel circuits. Do some extra research about that, and I'll be there to help you with that too through video conferencing today. But the key here in this indicator is to be able to understand how an electrical circuit shows the law of conservation of energy. How am I seeing energy always being conserved or transformed through an electrical circuit? So in your journal entry, guys, that's actually what I want you to focus on there. I want you to focus on how the law of conservation is illustrated through a circuit. A possible sentence starter you could use is an electrical circuit, or an electrical circuit shows how energy is conserved by, finish the sentence. If you want to draw pictures here to explain, you may do that too. So I will see you tomorrow. Look at the very bottom of the screen, and you're going to find that there's a link to the Hello Conference video conference that you can look at and talk to me, get some answers to questions. I've also sent that link through Remind, and it's in my YouTube at the bottom of this video. Please subscribe so you can be the first one to get the videos. Thanks so much, guys. Bye-bye.